The last two problems, 5 and 6, deal with functions where there's a fraction in the formula for the function. Again, we're finding the domain, the y-intercept, and the x or t intercepts, depending on whether our input is an x or a t value. Okay? And when I've got a fraction like this, the rule is that the denominator cannot equal 0. So when I'm finding the domain, 2t plus 5 cannot equal 0. Some people write that it equals 0, solve that, and then say t can be everything except the solution. I like to actually write in that it's not equal to that. So that's reminding me that that's the one thing that it can't be. All right, so I'm going to solve for t. So we'll get 2t equals negative 5. T would equal 2t would not equal negative 5. Just made a point about that. So t would not equal negative 5 halves. So the domain is all real numbers except for that. Now the directions, although I didn't write them down, the directions for this problem said to give things an interval notation. So if here's negative 5 halves, and that's not included, but everything else is, that basically means my domain is two intervals. Everything to the left of negative 5 halves and everything to the right of negative 5 halves. So in interval notation, this first interval would go from negative infinity to negative 5 halves. Negative infinity is not a number, so it's not included. Negative 5 halves isn't included because we said t can't be that number. Union, the second interval, is just negative 5 halves to infinity. So when you've got one value that's not in the domain, your domain is going to look something like this. All of the numbers up until that point and all of the numbers after that point. Okay, excellent. So if I want to find the y-intercept, again, to remember how to do that, I can think visually for this function. We've got t and y. The y-intercept is going to be where we're on the y-axis, so our t value will be 0. And then I want to find what the y value is. I will find that by plugging in 0. Now, since there are t's in two places, there are going to be two places where I'm going to be plugging in 0. So we'll have on top 3 minus there. I'm going to put my input. On bottom 2 times my input plus 5. And our input is just 0. So on top we get 3 minus 0. On bottom we get 0 plus 5. And so we get 3/5. Excellent. And then if I want to find the t-intercept, that's going to be where we're on the t-axis, which means our y value will be 0. So this was our y-intercept. If I want to find the t-intercept, that's going to be a point that gives me 0. So I'm looking for where does this fraction, 3 minus t over 2t plus 5 equal 0. Well, the rule for a fraction is a fraction is 0 if the top is 0, so I need 3 minus t to equal 0, and the bottom is not 0. So 2t plus 5 is not equal to 0. You'll notice that's what we solved for when we were finding the domain. So basically, if I get a solution that makes the top 0, but it's not in the domain of the function, it doesn't count. If I get a number that makes the top 0 and it is in the domain of the function, that's going to be the t value of my t-intercept. And I can see if I just add the 3 over, I will get 3 equals t. 3 does not make the bottom 0, so my t-intercept is 3, 0. Okay. So it looks like a more complicated equation to solve, but if it's a fraction, it's going to be 0 if the top is 0, provided the bottom isn't. Okay, so let's take a look at the first part of question 6, and then I'll let you try the second parts of those two questions on your own. So for question 6, we've got g of t is equal to 4 minus t over 3 minus the absolute value of 2t plus 1. So this is going to require that we review a little bit how to work with absolute value things. So if I'm finding the domain, the rule is the same. If I've got a fraction, the denominator can't be 0. So I'm looking for 3 minus the absolute value of 2t plus 1 to not equal 0. Now, I'm going to isolate the absolute value. So similar to when we had a square root, we get the root by itself before we deal with it. I'm going to get the absolute value by itself before I deal with it. So I'm just going to add it over to the other side. So we'll have 3 cannot equal the absolute value of 2t plus 1. So basically t is going to be everything except what would make this equal 3. Now when I'm working with absolute values, if this were a negative number, we'd be done because nothing can make the absolute value negative. But if that's a positive number, there are two things that could make that this true. Because if what's inside is equal to 3, the absolute value of 3 is 3. And if what's inside is equal to negative 3, that also has an absolute value of 3. So the way I deal with this is I say 2t plus 1 cannot equal plus or minus 3. There are two numbers that have an absolute value of 3, and 2t plus 1 can't be either one of those. Now, I can't solve them simultaneously. I'm going to have to break this up and say 2t plus 1 can't equal 3, and 2t plus 1 can't equal negative 3. Because in solving for t, and what t can't be, I'm going to do the same thing in both cases. I'm going to subtract the 1 over. So here, 2t cannot equal 2. Here, when I subtract the 1 over, though, I get 2t isn't negative 4. Notice I can't simultaneously subtract 1 from positive 3 and negative 3 because they give me different answers. And the two answers that I get are not opposites of each other. So I have to just write this as two separate things that I'm solving. So here this says t is not equal to 1, and this one says t is not equal to negative 2. So now I have two values, 1 and negative 2, that are not included in the domain, but everything else is. So now I've actually got 3 intervals in my domain. So the answer to part A is going to be the union of those 3 intervals. So we'll have from negative infinity to negative 2, union negative 2 to 1, union 1 to infinity. And it's parentheses around all of those endpoints. Okay, so part B is asking us, once again, to find the Y-intercept. So that's going to mean that my t value is 0. And to figure out the y value, I'm going to just plug in 0. So I'm looking for g of 0. And again, t is just a placeholder for my input. So I can copy the formula for this function. It's 4 minus my input over 3 minus the absolute value of 2 times my input plus 1. And what I'm plugging in for my input is just 0. So the top is just 4 minus 0, which is 0. Now, order of operations, these absolute value signs behave like parentheses. They're a grouping symbol. So I've got to work that out first. So it's going to be 3 minus the absolute value of 2 times 0 is 0, plus 1 is 1. Now the absolute value of 1 is just 1. So this is 4 over 3 minus 1. So that's 4 over 2, which is 2. That's going to be the y value. Notice it's easy when I have to sort of think about how to solve these things. It would be easy to think, oh, my answer is 2 because I've just solved an equation. That's why I kind of like having, I wrote down already that it's going to be an ordered pair so that I can remember that I've got to go back and just plug in what I get as the y value for that ordered pair. So in part C, I'm finding the T-intercept. That's going to be the point that's on the t-axis, point or points on the t-axis, so that my y value is 0. So we'll say 4 minus t over 3 minus the absolute value of 2t plus 1 has to equal 0. Remember, what that means is that the top is 0 and the bottom isn't. But I know the bottom will not be 0 as long as t is not one of these two numbers that we just ruled out, -2 or 1. Okay. So if I've already found the domain, basically I can just solve this, make sure I don't get one of those restricted values, and if I don't, then I'm good to go. And in this case, it looks like 4 is equal to t. So my t-intercept will be 4, 0. Okay, there's a second part to 5 and 6. So before you turn into the next video, give those a shot, and then the next video will just check your answers to those. If you've got the worksheet, you've already got those written down. If not, I'll write them down for you. The second part of 5 is h of x equals 3x over x minus 4. And the second problem from 6 is f of x equals 2x over 3 plus the absolute value of x minus 1. Okay, so I'll see you in the next video and we can go over those two.